of the simpler algorithm for regression is known as gradient descent. And there are multiple flavor of gradient descent: stochastic gradient descent, batch gradient descent, mini batch gradient descent, but fundamentally they're all very similar. But to understand gradient descent, you first need to understand the concept of a cost function. A cost function, put simply, is a way of measuring the error that the model does on the data. So if you have labeled data, you know what their value should be, and you can measure the performance of your algorithm on that data. And the cost function helps you then to decide how far from the truth your model is. So for a linear model, there is a very simple cost function for a linear regression model. And that's the mean square error, which essentially is equal to 1 over the number of observation times the sum of all of the prediction minus the actual value of those prediction, and we square this difference because if we square this difference, it always will be positive, and it also will be larger, which means that we have a better way of calculating or estimating the error of the model. But why is this relevant? Well, it's relevant because using this simple cost function, we can come up with a very efficient algorithm to estimate the regression through a number of data points. And that is known as gradient descent. So let's look at the principle of gradient descent. And of course, we can rewrite this equation using the linear algebra notation. So you just replace here the y by the h theta of x that we saw in a previous video. But why is this important? Well, it's important because this cost function, the mean square error, can be used to train linear regression using gradient descent. To understand gradient descent, you need to plot the mean square error or any cost function. So that's what we see here. We see here on the horizontal axis the theta, or the parameter space. So this is a 2D representation of a multidimensional problem. And on the vertical axis, we have the cost function, or in other words, the error that the model is doing on the prediction. So now let's imagine that we have a simple model. And in machine learning, we usually start by setting the weights and the biases of the model to random, relatively small values. So we can do this, and once we set the random weights and biases, we end up somewhere on this cost function. Now, the goal of gradient descent is to calculate the derivative of the cost function at the point that you have your data point. And that gives you essentially the slope, or the maximum gradient, the direction of the maximum gradient, thanks to the derivative. And the next step is to move in the direction, the negative direction of that gradient. That's why the algorithm is known as gradient descent. So once we move by the learning rate times the gradient. The learning rate is known as a hyperparameter. It's something that you have to set as a machine learning expert once you start training your model. The learning rate is essentially a small number that will determine how big a step you will take between each batch of learning. So once we move by the learning rate times the gradient, we get another data point. And of course, we do the same. Then we calculate the derivative of the function. And once we have the direction of the maximum gradient, we move by the learning rate times the gradient. And we do it again. And we do it again and again and again until the point where we reach a point where the derivative of the function is equal to 0. So no gradient, no slope on the derivative means that we have reached a minima. And you can see that very clearly here. We have reached the minimum cost function on this gradient descent. That means that this is the minimum error on the function. In other words, our algorithm is completely trained. Now, choosing the right learning rate is extremely important. That is because if you choose a very small learning rate, a learning rate that is too small, you will need to do the training a lot of times. So it will take many steps before your algorithm converges. And by converge, we mean reaches the solution. So that's computationally expensive. But choosing too big a step is even more problematic, because then what happens is as you move through a large step, you basically bounce back and forth between the two sides of your equation, and you never converge to zero. So if your learning rate is too large, you may never reach the minima, and that's of course a major problem. And another very important thing is that it is crucial for an algorithm like gradient descent that you apply standardization, because if your features are not standardized and the value range is too large, it will be very difficult for you to converge your algorithm, and that's going to be a problem. But sort of having said that, gradient descent is a simple yet powerful algorithm that is extremely convenient for regression.